Hello everyone, welcome back to ACSL. Today we are moving on from computer number systems to recursive functions, which is another very important topic in ACSL. As a reminder, we are going through the junior division, not the classroom or elementary or senior. This is because junior is the one with the most important topics. Senior has basically the same things, and elementary does not have as enough topics that are essential to ACSL. Moving on, today we will be going over ACSL's recursive function. So, to learn a little bit about recursive functions are functions that call itself, or it uses it to relearn and runs it again if something happens. So it says that so some common recursive functions that you've probably encountered is the Fibonacci numbers. So 0, 1, 1, 2, 3, and so on. So Fibonacci numbers have the equation f of n, or the function n, that you plug in the number n. You do the function n again and the function of n minus 2. So if you find f of 10, you will do f of 10 equals f of negative 1, or n minus 1, so that's 9, and then 8. So then you'll stop when you reach 1, 0. And you write the function as this. So n, if n is greater or equal to 1, and f of this if it's greater than 1. So for the people who code Python, here is a code that has the Fibonacci sequence. So you define the function that Fibonacci of x, and if x is less than or equal to 1, then you will return x. So as long as this x is less than or equal to 1, you just stop the function. If it is greater than 1, then you will return the function calling itself. For the people who do not know Python, you can go over there and check our courses on that. It will be very useful for the future ACSL categories. Yeah, so moving on. A factorial function is a function that calls itself factorial times. So you can see the recursive function as f of x, curly bracket, and then you return 1 if x is equal to 0, and then you return x plus f of x minus 1 if x is greater than 0. So that means that you're going to do the function again and again and again until x is equal to 0. So with this definition, the Python implementation of this factorial function will be if it is 0, then you return 1, as here, and if it's not equal to 0, then you will return x times the factorial of that. So you just return this if it's that, or it is not this. And the wiki gives you some definitions of indirect recursion, multiple recursion, and an out of memory error. So the indirection recursion is when a function calls another function, and then which will eventually call the original function. And here's an example. A calls B, and then before the B exits, the function A is called in B. So it says either by B or a function that B calls. So A could, for example, in here, A could call B. Say, okay, so this function I call B, which is another function. The B could either call another function, let's say C, and then that returns and that calls A, or B could just call A. So that is a indirection recursion. A multiple recursion, like the Fibonacci number function, is when a function has multiple self-references. So A calls A, which calls A, which calls A. And then an infinite recursion is when a recursion function never returns because it keeps itself. So regularly, like the Fibonacci number function, it calls A minus 1 and it checks if A ever becomes 1, then it stops. But an infinite is when it always calls itself forever, so it doesn't change anything. It just keeps on calling itself without returning anything. And it says it keeps calling itself, and it says the program will eventually crash because it will go on forever. So it says this ACSL category, recursive functions, focuses on mathematical recursive functions rather than programming algorithms. So it's mainly just math and logic than programming. And you can see some sample problems. So let's do some in the next video. So thank you for watching this, and we'll see you.